Sedna, meanwhile, is creeping along as the centuries roll by. When Mike and his team discovered Sedna with the 48-inch telescope at Palomar, it was in the part of its orbit closest to the Sun. Sedna only spends about 200 out of its 11,000-year orbit close enough and bright enough to be detected with that telescope. So out of the 110 centuries it takes to orbit, Mike and his team found it during the 2 when it was closest enough to see. Now, it could definitely be that they just got lucky, but what if there were lots of Sedna-like objects just out there waiting to be discovered? In any given century, there would be a handful of those objects close enough to be detected with a telescope of that size. And as it turns out, there are several objects with orbits like Sedna's. And it is these objects that are showing us evidence that there might be a 9th planet out there. You can see the evidence if we narrow our view of the Kuiper Belt down and look specifically at the Sedna-like objects that go out the furthest, so they are the least affected by our 8 planets. See anything curious about these objects? See how all of their orbits are, kind of lined up on one side? It might not be perfect, but they're definitely extending to the right and not the left. Turns out there's only about a 1 in 10,000 chance the orbits would be aligned like that. The even stranger thing is, over time, these orbits should all precess, like we're seeing now. They should spin around the Sun at different rates, so even if they did start off aligned, they wouldn't stay that way over a few 100 million years. Unless something is keeping them aligned. Something massive, something very far from the Sun. We call that something Planet 9. This computer simulation shows how Planet 9 would affect the orbits of distant Kuiper Belt objects. These 4 small circles are the orbits of our gas giant planets. The very large orbit is Planet 9. We're starting the simulation in the very early days of the solar system, so these orbits are a random distribution of early Kuiper Belt objects. Over the next minute, we'll watch as 4 billion years go by. The gravity of Planet 9 tugs and pulls on the Kuiper Belt objects, changing their orbits and even ejecting some of them out of the solar system altogether. It was simulations like these that Mike Brown and Konstantin Batygin used to predict the existence of Planet 9. Brown and Batygin ran multiple computer simulations to figure out what mass and orbit Planet 9 would need in order to explain the orbits of objects like Sedna we have seen. Eventually, things get pretty cleared out. We see a lot of orbits precessing in the Kuiper Belt and then a few objects to the right with their orbits all extended in roughly the same direction, just like what has been observed in the actual Kuiper Belt. It seems that Planet 9's gravity sort of acts like a sheepdog herding sheep. It keeps them from straying too far from one another. Planet 9's orbit is on the left, and these objects like Sedna are on the right. So, where is Planet 9? Well, the simulations don't tell us exactly, but what they do give us is a good range of possibilities of where to find it. Each of these orbits is one of those possibilities, and any of these orbits could explain what we see. When viewed from the Earth's perspective, these orbits cover quite a large portion of the sky. And as the Earth orbits the Sun, we can only see some of the areas at certain times of the year. It sort of feels like finding a needle in a haystack. Okay, maybe not that difficult. I mean, the simulations at least tell us which part of the haystack to look in, but it's still a lot of work to find it. There is a lot of the sky that needs to be searched. That's why finding undiscovered objects in our solar system is no easy task. Since Planet 9 is so far away, it'll be extremely faint and require a very large telescope to find, much larger than the 48-inch telescope at Palomar. So, Mike has come here to the big island of Hawaii, almost 14,000 feet above sea level on the summit of Mauna Kea, to begin his search with the Subaru telescope. This telescope is operated by the National Astronomical Observatory of Japan and is equipped with something known as the Hyper Supreme Cam, which is a huge camera capable of imaging large areas of the sky. This camera has 870 megapixels. For comparison, your smartphone has about 12. And it's attached to a telescope over 25 feet across. This camera makes Subaru the best telescope in the entire world for finding Planet 9. What we're watching now is the first night of Mike's official search for Planet 9. The telescope is scanning the sky, looking in the areas the computer simulations told us this elusive planet might be hiding. It will image each area 3 times during the night, and then compare them. If we get lucky, in one of them, there will be something moving very slowly. Fortunately, the weather cooperated and conditions were pristine for the first night of the search. Now, many other astronomers are joining the search for Planet 9 as well. Not only here on Mauna Kea, but utilizing telescopes all around the world and spacecrafts throughout the solar system. Hopefully soon, one of them will observe Planet 9. It might not happen tonight, or honestly, even in this decade. But when it does, our solar system will suddenly get much, much bigger. So what do we even expect Planet 9 to be like? Well, its average distance from the sun is likely about 8 to 10 times further than Pluto. To put that in perspective, light from the sun takes about 8 minutes to get to the Earth, and 5 hours to get to Pluto. The light travel time to Planet 9 would be more like 2 whole days. And it'll be big too. Planet 9 is likely 3 times the size of Earth and 5 to 10 times as massive. That is up to 5,000 times more massive than Pluto. What does it look like? We really can only guess for now, but we do expect it to be a gas giant, sort of like a mini Neptune. Will we find beautiful rings? A family of moons? Only time will tell. This far out in the solar system, the sun looks just like a bright star, with the orbits of the planets out to Neptune clustered around it. So far, no one has observed Planet 9, but when they do, it'll be the scientific discovery of the century, a new 9th planet in our solar system.
My daughter was 7 years old at the time that we went to Norway for the prize. And you know how 7-year-olds are. She thought that I'm basically just kind of boring, and she would roll her eyes at everything I did. I would try to tell her about the solar system or these discoveries, and she just didn't care. And then we went to Norway, and I got up on stage, and I got a gold medal from the King of Norway. And she still doesn't really know what I do or care that much, but she thinks it must be like slaying dragons or something for this gold medal. It was a pretty exciting thing, just even for that aspect of it.
You too can join the search for Planet 9. Head to zooniverse.org and check out Backyard World's Planet 9 to do your own classification of these images. Thank you all so much for joining me for Planet 9. If you have any questions, my name is Kira, and I'll be at the back desk. Otherwise, have a wonderful rest of your evening here at the Adler.